Hello and welcome to this video on algebraic division, factor theorem and remainder theorem. This corresponds to the Edexcel module C2 and it's chapter 1. So if you're following along in an Edexcel book, then that's where you can find this. So as I said, we're going to cover algebraic division, factor theorem and remainder theorem, which means that we need to start off with some little basics of algebra and fractions. So we're going to start with, if I gave an expression such as 3x squared plus 2x all divided by x, how would that simplify down? Well, simply we can look at each term on the top of the fraction, on the numerator, and we can say, well, what happens when we cancel an x out? So 3x squared, if you cancel an x out, cancel the x on the bottom with the squared, you get left with 3x. Yeah, and 2x, if you cancel an x out on the bottom, you get left with 2. So that means that 3x squared add 2x divided by 3x squared plus 2x divided by x cancels down simply to 3x plus 2. Okay, what else can we look at before we need to move on? Well, we need to look at what happens if we've got factored algebraic expressions. So let's take, for example, the fraction x plus 3, bracket 3x plus 4, close bracket, open bracket, x minus 2, all divided by x minus 2. What happens here is that simply the x minus 2 on top can cancel with the x minus 2 on bottom, and we'd be left with x plus 3, 3x plus 4. Perfect. So what if we have some sort of quadratic equation, for example, and we want to divide it by some lower order polynomial? A polynomial is just anything that's got powers of x in it. So if we had, say, something like, let's say x squared plus 5x plus 4 divided by x plus 1. How would we go about simplifying this? Well, the first thing that we can try is we can try to factorize the numerator. We can attempt to factorize this thing up here. So if we want to factorize x squared plus 5x plus 4, we know we're going to want to put it into two brackets, and that each of those brackets is going to have x to the power of 1 in them. Now we need to figure out what goes here and what goes here. And the way that we do that is by looking at the factors of 4. Okay, so we've got 1 and 4. And we've got 2 and 2. Right, well, 1 and 4, can they combine in some way to make 5x? Well, 1 plus 4 is 5, so immediately that'll work for us. We can say, therefore, that it factorizes to x plus 1, x plus 4. Perfect. So now we can go back up here to our original fraction, and we can rewrite this x squared plus 5x plus 4 all over x plus 1. We can rewrite it as x plus 1, x plus 4, all over x plus 1. And now, just like before, we can cancel the x plus 1 with the x plus 1, and we get left with simply x plus 4. Perfect. Right, now what happens if either we can't factorize the numerator, we can't factorize the polynomial, it's maybe too high a power of x, something like x cubed or x to the power of 4 or 5, or we just can't see a way of factorizing it. It might factorize, but we can't figure out how to do it. What do we do then? Well, that's when we use something called algebraic division. Okay, and we're going to learn this by just simply doing an example. And the example we're going to use is we're going to simplify this next fraction, and this fraction is at 3x cubed plus 7x squared minus 14x minus 24, and that's all divided by x minus 2. Right, there's a very simple and nice, easy method that we can use to do this. And it will look a little bit familiar to you if you remember way back in your primary school days of doing the bus shelter method for division. So the way that we do this is we set up this bus shelter, which looks like this, and we put our numerator inside the bus shelter. So we have 3x cubed plus 7x squared minus 14x minus 24 in here. And then on the outside, we have our denominator, x minus 2. Excuse me 2 seconds. Right, now what we do is we only look at this x term here. Okay, we ignore the minus 2 for now completely. And what we say is, what do we need to times this x by to make 3x cubed? Okay, or in other words, what's 3x cubed divided by this x? Okay, now we know from the first part that if we've got something like 3x cubed divided by x, it's just 3x squared. And what we do is we write that above the column here that's got the x squareds in. So we write 3x squared up there. Now what we do next is we multiply this term by this whole term here, the x and the minus 2, and we write it underneath what we've got here. Okay, so 3x squared times x minus 2. Well, 3x squared times x is 3x cubed, and 3x squared times x minus 2, times minus 2 is minus 6x squared. Okay? Right, now what we do is we draw a line under this and we simply subtract everything on the bottom from the top. And all we need to really look at is these first two terms here and these two terms here, because nothing will happen to these because there's effectively zeros under here. Okay, so we have 3x cubed minus 3x cubed. And that gives us 0. Then we have 7x squared minus 6x squared. So that's the same as 7x squared plus 6x squared, which would be 13x squared. Perfect. Now what we do is we bring this next term here, this minus 14x, down, and we say minus 14x. Now we repeat the process again. So we look at simply the x, and we look at the 13x squared, and we say, what do we need to times x by to get 13x squared? Or in other words, what do we divide? What's 13x squared divided by x? And the answer is just 13x. So that goes up here above our x column. And then we do the same as before, and we say, right, we need to times this 13x by everything over here on the left-hand side. So what's 13x times x? Well, that's 13x squared. What's 13x times minus 2? Was minus 26x. Lost our minus up there. Okay, and then we draw a line, and we take the bottom away from the top again. So we have 13x squared minus 13x squared, which is 0. And then we have minus 14x minus 26x, which is minus 14x plus 26x, which gives us plus 12x. Okay, then we bring the minus 24 down again. We put that there. And we start again. So we look at the x, and we say, what do we need to times x by to get 12x? The answer is plus 12. And then we say, right, what's 12 times x minus 2? And 12 times x is 12x. And 12 times minus 2 is minus 24. Draw the line, take them away. 12x minus 12x is 0. Minus 24 minus minus 24 is 0. So we end up with nothing. So what we can now say is actually, back at the top here, this 3x cubed plus 7x squared minus 14x minus 24, all divided by x minus 2, is equal to 3x squared plus 13x plus 12, which came from there. Perfect. Let's look at another example. Let's look at the example, and we'll do this one a little bit quicker. We'll speed up slightly. Let's look at 8x cubed plus 56x squared minus 2x minus 16, all divided by 2x plus 1. Right, so we set our bus shelter up just like before. We have the 2x plus 1 on the outside. We have the 8x cubed plus 56x squared minus 2x minus 16 on the inside. And we look at the 2x alone, and we say, what is 8x cubed divided by 2x? Or what do we need to times 2x by to get 8x cubed? And the answer in this case is, well, if we divide it by x, we get 8x squared. Divided by 2, we get 4x squared. And that goes over the x squared column. Now we want to multiply 4x squared by 2x plus 1. So 4x squared times 2x, 8x cubed. 4x squared times 1 is plus 4x squared. Draw our line, and we subtract the bottom from the top. So we get 0 there, and we'd get 56 minus 4, which is 52x squared. We bring the minus 2x down. Okay, now we look at it again. 2x into 52x squared. Okay, well, 52 divided by 2 is 26. And then the x squared divided by the x is x. So that gives us plus 26x. And we multiply the 26x by the 2x plus 1. And we get 52x squared plus 26x. Draw a line, take it away. That gives us 0. Minus 2 plus 20 minus 26 is minus 28x. And we bring the minus 16 down. Okay, now we say, right, 2x into minus 28x. What does that give us? Well, it gives us minus 14. So we multiply that out. Gives us minus 28x. Minus 14 times plus 1 gives us minus 14. Draw a line. Minus 16 minus minus 14 gives us minus 2. Okay, interesting. Now last time when we got down to this stage, we had a 0 here. This time we've got a minus 2. Well, what happens if we try and keep going? Well, 2x into minus 2. Can we do that? Well, no, there's no more powers of x to cancel, so we can't really do that division. So what we can say is that what you would have said when we did the bus shelter method originally is that this fraction at the top would give you 4x squared plus 26x minus 14, remainder minus 2. But what we say instead is this at the top. We have this fraction reduces to 4x squared plus 26x minus 14, and then we've got minus, and we've got 2 over 2x plus 1. Okay, this 2x minus 2x plus 1 is really, really important. Okay, because what this is really important. What this is this here has still got to be divided by 2x plus 1. Everything else has been divided by 2x plus 1. It's just this last term here, minus 2, what we got left over that hasn't. So all we simply have to do is just tack it on the end with a over 2x plus 1, and we've got our answer. Okay, perfect. Right, let's move on again. There's one little nuance that can happen when we do this. And what it is, I'll do another example and you'll see where we get into trouble. Let's attempt to simplify this fraction. X cubed minus 3x minus 2 divided by x minus 2. Okay, let's see what happens when we try this one. Right, well, let's set it up the same way. Let's do our bus shelter. We put x cubed minus 3x minus 2. We have the x minus 2 out here. Right, let's start as we normally do. X into x cubed. Okay, well that's x squared. Okay, well I haven't got an x squared column, so I'm not really sure where to write it, but that'll be fine. I'll write it up here. That'll be fine. Okay, let's multiply it out. X squared times x gives us x cubed. And then x squared times minus 2 gives us minus 2x squared. Draw our line. Take them away. X cubed minus x cubed, 0. Minus 3x minus 2x squared. Oh, now, they don't really cancel in the same way. I can't really take one away from the other in the same way that I have been before. So what do? Well, like this, we can't really do anything. So this doesn't work. But luckily, there is a way that works. And this is how we do it. We set it up exactly the same, x minus 2 on the outside, but this time we put in terms for x squared, but with a factor of 0 outside the front. So like this, we say plus 0x squared minus 3x minus 2. Okay, so it's got a coefficient of 0 by the x squared. So effectively this term is actually 0. We've put it in to help our method work. So now if we use our method, x into x cubed, well, that's x squared. Oh look, now we've got an x squared column, that's good. And we can multiply it out and we get x cubed minus 2x squared. We take that away and we end up with 2x squared here and minus 3x. Multiply, right, x to 2x squared, that's plus 2x. Multiply it down, 2x squared minus 4x. That gives us positive x minus 2. X into x, that's 1. And we get x minus 2. Take it away, gives us 0. So the answer at the top simply becomes x squared plus 2x plus 1. Perfect. That's everything you need to know about algebraic division. It's very useful. You'll use it later on in C3 and C4 when you do integration. You'll sometimes be given a fraction, something like this, something like the examples we've looked at, and you'll be asked to integrate it, and you'll have no idea how to do it because it's some crazy complex thing and it doesn't look like anything you've done before. But you can use algebraic division to work out what it is in a much simpler form, something like this, and that you'll be able to integrate. So it's really useful, it's good to learn, and it's really useful to know. What's next? Well, now we're going to look at something called the factor theorem and the remainder theorem. These are really useful because they can save you a lot of time if used correctly. They can be used to sort of do different style of questions, so you definitely need to know them, and they can save you much time in the exam if you're given an open question. What is the factor theorem? Okay, well the factor theorem says basically this. If we have some polynomial f of x, if f of, say, a is equal to 0, then x minus a is a factor of f of x. Okay, so I'll say that again. If we've got some polynomial, which is just some equation with powers of x in it, and f of a, where a is a number, is equal to 0, then x minus a is a factor of f of x. Okay, let's look at this. So, f of x, let's let f of x equal 3x cubed plus 7 x squared minus 14x minus 24. Let's calculate f of 2. Right, well we've got 3, 2 cubed, plus 7 times 2 squared, minus 14 times 2, minus 24. So we've got, what, 2 cubed 8 times 3 is 24. Right, 2 squared is 4 times 7 is plus 14. Sorry. Plus 14. Plus 28 even. And then we've got 2 times 14, that's minus 28. And we've got minus 24. So clearly the 24s cancel, the 28s cancel, and we get 0. Okay, brilliant. What does that tell us? It tells us that if we factorised f of x, one of the factors, one of the brackets would be, therefore, so this symbol I've just drawn here means therefore, x minus 2 is a factor of f of x. Okay? What does that look like? Well, we can work out what it is. We can basically say that we can write f of x, which was this term up here, this 3x cubed plus 7x squared minus 14x minus 24, as x minus 2 bracketed times some other bracket. Okay, now what I'm about to do next, if you don't feel comfortable with it, you don't need to do it. It's something that can save you time, but it only works if you're really happy with factorizing polynomials. It's something that you could get better at over time, but don't worry too much about it if you can't do it. If you're really pushing for like an A star or something, then it's the kind of thing that hopefully by the end you'll be able to do and it will work out. What we're going to do is we're going to work out what this bracket is here by knowing what this is. Okay, what do I mean by that? Well, we know that in f of x we have to have some term 3x cubed. Down here that means that we're going to have an x squared term because we've got an x here. And there's only an x here and there's only going to be one x squared term here, so it has to be 3x squared. Okay? Right, what else do we know? We know at the end there's going to have to be a minus 24. The only way that's going to happen is by a number here, minus 2, our constant, something that's not got a power of x in it, times another constant here. Well, we've got minus 2 here, so that's going to have to be times by plus 12 here to make minus 24. All we've got to do now is fill in this middle term. And how do we do that? Right, well, we want plus 7x squared. Okay, well we've got minus 6 from here, from the minus 2 times the 3x squared. That gives us minus 6x squared. So we need what? Plus 13x from here by an x times this. So this becomes plus 13x. Okay, and that we can further factorize and say 3x, and this will work out 3x plus 4, x plus 3. So as you can see, now that we've fully factorised f of x, thing up here, we get 3 brackets, and one of them is our x minus 2, which we knew was going to be a factor because of the factor theorem. Okay, this last bit here, if this just confused you, don't worry about it. It's not that important. Okay, what I want you to focus on is that x minus 2 being a factor, and we know that because f of 2 is 0. That's what I want you to focus on, the factor theorem. Okay, brilliant. So we've got one more theorem. We've got the remainder theorem, which the remainder theorem says if we have polynomial f of x, if we calculate f of a, this gives us the remainder when we divide f of x by x minus a. or in a slightly more general way, f of x, f of a over b gives us remainder when dividing, f of x by bx minus a. Okay, so what does that look like? Well, let's let f of x equal 8x cubed plus 56x squared minus 2x minus 16. Let's say that we wanted to divide that f of x divided by x, let's say plus 4. Okay, and we just want to know the remainder. So we calculate f of minus 4. Okay, do you see that? So when it's x minus a, we calculate f of a. So if it's x plus 4, we calculate f of minus 4. Okay, and that will give us, 8 minus 4 cubed plus 56 times minus 4 squared minus 2 lots of minus 4 minus 16, which gives us what? Minus 4 cubed is minus 64 times 8. So that's what's minus 64 times 8. Minus 64 times 8 is 512. So it's minus 512. Right, now this time we've got minus 4 squared, which is 16. So we've got 16, and we want to times it by 56, which is 16 times 56, 896. That's okay, plus 896. And then we've got a minus 2 times minus 4, which is plus 8, and a minus 16. Clearly, if you put that in a calculator, you can just see that does not equal 0. So we know it's definitely not a factor. And it does equal, what does it equal? 896 minus 512 would be 384 plus 8 minus 16, which 376, I think. So we have a remainder of 376 if we were to divide f of x by x plus 4. That's what the remainder theorem does. So why is it useful? Well, it can quickly tell us if something is a factor or not, much like the factor theorem, which is really helpful, and it will be used throughout the questions to you may be told what the remainder is, and there might be some unknowns in the question, and you can use the remainder theorem to work out the unknowns. It's really, really helpful. Okay, that's it for this tutorial. Please leave any comments and I can change things, or let me know if there's a topic you'd like me to cover and I will cover it in a video. Thank you very much.